Okay, what's up? This is the multiple choice section of the lower sixth test on electricity. I'm going to run through these one question by one to make sure we all know how to solve this. So, which is equivalent to the ohm? So, thinking about this, what do I want to do? Well, I know that R is V over I. So I know that maybe I can work something out here. So let's think about what voltage actually means. So if we do the actual units, voltage is the energy per unit charge. Current is the charge per unit time. Would probably be the first way to think about this. What does this look like then? This is ET over Q squared, which would have units of joule seconds per coulomb squared, or joule, where's that? Yeah, that's going to be B then, isn't it? Joule seconds per coulomb squared. Okay, question 2. A gas containing doubly charged ions flows to give an electric current of this much. So how many ions pass a point in 1 minute? So if I work out the total charge that flows, that might help me. So the total charge is Q equals IT. So this is 0.64 times 1 minute, but we need it in seconds. So 0.64 times 60. So on my calculator, 0.64 times 1 times 60. So this is 38.4 coulombs. Okay, so we could then write another equation that says something like the number of charged ions multiplied by the charge on one ion equals the total charge. That would make sense, wouldn't it? So let's rearrange for n. So this would be big Q over small q. I've just made up those q's there. That's just me making them up. Big Q is 38.4. And then what's the charge on one of these ions? Well, they're doubly charged. So they're going to be 2 times 1.6 times 10 to the minus 19. Plug that into my calculator. 2 times 1.6 times 10 to the minus 19. That gives me 1.2 times 10 to the 20, and therefore C is the correct answer here. Question 3. Which row gives the position and ideal resistance for a voltmeter? Well, I want voltmeters to have a very high resistance, and I want them to be in parallel. So what have we got? In parallel with X, and then infinite resistance. Yeah, C is going to be the correct answer for that one. Question 4. Combined resistance of N identical resistors connected in parallel is Rn. Which statement correctly describes the variation of Rn as N increases? Okay, so when we're in parallel, let's say we've got one resistor. This would have resistance R. And then if we got another one, this would be R over 2. So we can say that as N increases, the combined resistance goes down. Is it going to be a kind of linear relationship? No, I don't think so. If you plot a graph of, I think, something like N against R, you'll see it's something like that. We have to apply, 1 over R total equals 1 over R1 plus 1 over R2 and so on. You get some kind of a graph like this. So Rn decreases as N increases, so it's either A or B. But it's going to be B. It's not a linear relationship. So question 4 is going to be B. Question 5, what's the effective resistance between P and Q? Okay, so we've got to combine these together bit by bit. So first thing we can do is combine those two, which are in parallel. So this is 1 over 6 plus 1 over 3, and then 1 over the answer. So those two together are effectively worth 2 ohms. So I guess let's put a box around them. They're worth 2 ohms. Then I've got some in kind of series with each other, right? This, and this are in series. So this is, actually I should say not 2 ohms, but 2R. That's 2R. Now I've got R plus 2R plus R. So all of these guys together, woo, that went weird. All of those guys together are going to be 4R. And then I've got 2 4R as in parallel. And 2 4Rs in parallel will give me a final answer of 2R. So 5, the correct answer is going to be B. Question 6. Circuit below, each have the same resistance, okay. Which two connections with the voltmeter read 0? Okay, so I need to look for 2 points of equal potential. Okay, so what I could imagine is if I connected, like, W and S will be at the same potential, won't they? Because they've both, like, if you imagine the current flowing, like, around here like this, they've both gone through one resistor. They'll have some potential drop, some voltage drop across that first resistor. They'll both be at the same place. So W and S will be at the same value, and U and Q will be at the same value as well, because they're both at the same points in the circuit, effectively. So the correct answer will be Q and U. So this one is, question 6 is A. Question 7, which row shows the readings on the ammeter and voltmeter? Okay, so my voltmeter's in the wrong place, the first thing I'm noticing. So my voltmeter is going to be, that is weird, isn't it? Negligible internal resistance, okay. Do I have a value for the voltmeter? No. Okay. Well, the voltmeter has a very, very high resistance. So if you split these two up as like a potential divider, you can imagine that the voltmeter is going to have almost all of the voltage across it. And in fact, therefore, it will have almost the full 1.5 volts. So therefore, I know the voltmeter is going to show 1.5 volts. Therefore, what's the current through the circuit? What's the current through the circuit? I have got no idea how to solve that from here. Do I? No? The current through this section right here, you can see me getting stuck. I hope you enjoy that. The current through here is going to be negligible, right? We can basically say 0 amps because the voltmeter's got such a high resistance that there's basically no current flowing through here. So let's just work out the current through the bottom section of the circuit. I equals V over R, 1.5 over the combined resistance of 20. That's going to be 0.075 amps. So therefore, the correct answer will be B. So 7 will be B. Yeah, I hope you like seeing me kind of get stuck on one. Like, I haven't solved these yet. So what I want you to see from there is like the thought process of like, oh my God, I don't know what to do, but like just stay calm and like write down stuff you know until you figure it out. Okay, question 8. Some cells here, each 3 volts EMF, negligible internal resistance, 12 ohms there. Okay, what's the readings on the voltmeter and ammeter? Okay, so when they're in parallel like this is a 3 volt cell, this is a 3 volt cell. But so you can sort of appreciate that if you just follow one loop around the circuit like this, there's just 3 volts, right? So this voltmeter will read 3 volts as well. So I know that these are going to be the correct answers. We have this resistor, R is 12. So work out the current through it, I equals V over R, 3 volts across it, 12 ohms. 1 over 4 is 0.25. So this one, so 8 is going to be A. Question 9. A student carries out an experiment to determine the resistivity. Measures the end of the wire and the current, measures the length of the wire with a ruler and the diameter using a micrometer. Each measurement is made with an uncertainty of 1%. Which measurement gives the largest uncertainty in the calculated value of the resistivity? Don't know. Ruler, micrometer. Well, the ruler is not very precise, but each measurement gives an uncertainty of 1%. So RA over L is this. So if we were going to do the percentage uncertainties, what's she measuring? Voltage and current. So this is going to be V over I. This is going to be pi d squared over 4. and this is going to be L. So if you look at all of those things, the voltage appears once, the current appears once, the length appears once, but the diameter of the wire is a squared. So if we were doing percentage uncertainties, if we wanted to work out the percentage uncertainty in rho now, this would be the percentage uncertainty in V plus the percentage uncertainty in I plus 2 times the percentage uncertainty in D plus the percentage uncertainty in L. So therefore D appears twice and is going to have the biggest effect. So 9 is going to be the diameter. Question 10, is this the last one on the multiple choice? Yeah, it is, cool. Question 10, okay, so we can say for the first one, what I always like to do with these is write something out. So R equals rho L over, I guess, pi d squared over 4. Okay, it's fine, we can write that like that. And then let's kind of write that out a bit nicer. So 4 rho L over pi d squared. So this is our sort of first wire right here. And then we've got another conductor, which is a little bit different. In this case, R equals, what's rho? Still rho, still L. We'll bring that 4 up straight away. And then we've not got pi d squared, we've got pi times d over 2 squared. This is going to be 4 rho L over pi d squared over 4, which is going to be 16 rho L over pi d squared. So now, when we compare these two, we compare this one and this one, we can see that the second conductor has a resistance 4 times bigger, right? This is times 4. So 4R instead of R, which gives the answer as B. All right, I hope that was helpful for the multiple choice and you could see the ones that you wanted to go over. Cool, peace.